Thanks for joining us for this special edition of Apple Seminar for One. Over the years, Apple has worked with many other companies and with many industry organizations to develop technologies that address the needs of our customers. None of these alliances has received as much attention as our wide-ranging agreement with IBM. That's understandable given the scope of this alliance and the impact that it can have on the computer industry. This alliance is particularly significant for information systems professionals because now Apple and IBM will be working together to build products that you need today, as well as the foundation technologies for enterprise systems of the future. It brings together the greatest strengths of Apple and IBM. Our alliance springs from a vision shared by Apple and IBM, a vision of how computing, particularly enterprise computing, is evolving. The agreement between IBM and Apple involves 5 technology initiatives. The first addresses the immediate needs of our customers for greater interoperability. Interoperability will be critically important as large organizations progress to client-server computing. So our first aim is to assure interoperability between Apple's Macintosh product family and IBM's systems and networks, in many ways and at many different levels. The second initiative involves not only IBM but also Motorola, Apple's long-standing technology partner and microprocessor supplier. Together, Apple, IBM, and Motorola will launch a new line of reduced instruction set microprocessors called the PowerPC. The third initiative is PowerOpen, a new open systems platform based on industry standard Unix. PowerOpen will be jointly developed by Apple and IBM, and it will be available from both companies and will be licensable to other vendors as well. The fourth and fifth initiatives are 2 equally owned joint venture companies that Apple and IBM are forming. Now, the first of these is called Taligent, and it will develop and deliver a completely object-based operating system platform. The Taligent system will provide a smooth upward migration path from the Macintosh, and it will run on a variety of microprocessor platforms, including the processor families from Intel, Motorola, and of course the PowerPC RISC processor. The second joint venture company is called Kaleida, and it is also a software initiative. Kaleida will develop and market critical software building blocks to better enable multimedia computing. Growth without disruption has been one of the hallmarks of the Macintosh since its introduction in 1984. This alliance ensures that we can continue our unmatched track record for growth of the Macintosh without disrupting the investment that our customers have made and are making in application software and Macintosh hardware. And I should emphasize that the Macintosh is and will continue to be our primary business through the 90s. We'll continue to improve and expand the Macintosh product family to bring an ever-growing range of price and performance options. Now with IBM's stamp of approval for Macintosh and with their engineering support for Macintosh integration, we can expect that Macintosh will become more widely recognized as an advanced platform for client-server computing. In this seminar, we'll take you beyond what you may have read in the press about our alliance with IBM to give you some important details about the work that we're doing. And if you're already using Macintosh personal computers, you'll see how your investment will be protected and enhanced. And if the Macintosh isn't already a part of your computing strategy, you'll see why it now makes more sense than ever before to put Macintosh to work in your organization.
Hi, I'm Russ Christoff, and I'll be your host for this program about the much-discussed technology alliance involving Apple Computer, IBM, and Motorola. We'll be talking in detail about this historic agreement that was signed on October 2nd, 1991, and will explain what it means to information systems professionals. The immediate goal of the alliance is to better integrate Macintosh personal computers into IBM environments. In the long term, it will lead to the creation of a set of hardware and software computing platforms that will be the foundation for a new era in enterprise computing. And because these industry giants will be collaborating to create foundation technologies, it will help information systems builders plan for the future. The alliance involves 5 technology initiatives, and we'll discuss each of them in this seminar. To better understand what these initiatives will change, and importantly, what they won't change, It helps to review a bit about the connectivity and architecture of Macintosh. So we'll do that, too, in this program. The first products of the Apple-IBM Alliance are aimed at improving the integration of Macintosh and IBM systems. Ellen Hancock is Corporate Vice President and General Manager of IBM's Networking Systems Division. She outlined the interoperability goals of the Alliance on October 21st, 1991, at the NetWorld Trade Show in Dallas, Texas. First, she explained that Apple has licensed IBM's 16-megabit token ring technology and incorporated IBM's chipset in a new network adapter card for the Macintosh, which premiered at NetWorld. Then, she enumerated the other key parts of the initiative.
2. IBM plans to license the AppleTalk source code to improve the Macintosh's performance and function as a client to an OS/2 server, and to allow the Macintosh to share files, query databases, and access a broad range of communication services. The third part of the Networking Alliance will call for IBM to assist Apple in its implementation of the Advanced Peer-to-Peer Networking, APPN. This will give the Macintosh full access to APPN directory and routing services. And as many of you know, APPN is an extension of IBM's Systems Network Architecture, SNA, and makes SNA networking much easier. 4, we plan to integrate the Macintosh into our network management offerings so that customers can manage networks incorporating Macintoshes either locally through IBM's LAN Network Manager or centrally through our NetView family of network management offerings. And 5, we will work to provide improved communications between the Macintosh and our AS400 mid-range systems for improved access to AS400 data and application resources.
Macintosh personal computers already offer an impressive level of connectivity and interoperability with IBM systems. Let's look first at local area networks. We'll examine the capabilities already in place and see how the alliance with IBM will complement them. Local area networks are the foundation for collaborative computing and for client-server applications. But setting up and managing local area networks is a significant ongoing challenge, which only gets worse as networks grow larger and more complex. Apple's leadership in masking the complexity of computing has been extended to relieve systems builders and administrators of many of the headaches of LANs.
Well, I think, the Apple's ease of use that was originally just, on the screen for the Macintosh has been well translated to the networking aspect of what Apple has done, and Apple has continued their ease of use lead there, particularly over the more traditional PC network where it's kind of an erector set approach. There's a lot of cobbling different things together.
The benefit of networking ease of use to an IS organization really comes in several different ways. First of all, there's ease of installation and setup. Putting a Macintosh onto a user's desk, into a user's work environment, is a much easier, much simpler process. In many cases, the user can do that themselves. It's not a case of having to go through a long process of getting a config.sys or an autoexec.bat file correct. You pull it out of the box, you plug it in, and it works.
When we built connectivity into the first Macintosh, our immediate objective was to enable people to connect to computing resources without the hassle of configuration that plagues people who have to set up and administer local area networks. On the Macintosh, connection is accomplished with the chooser, a window that users open to view and choose network resources such as printers, file servers, and communications gateways. I'll attach this Macintosh to Apple's corporate network just by plugging in a cable. We're on the network instantly, without any intervention from a network administrator, because Apple has provided a self-configuring network system that's built into every Macintosh. Here's a list of all the network zones, and we can see all the printers available on each of those zones. To select one, I just point with the mouse and click. If I choose Print from the menu bar of any Macintosh application, the file will be printed on the printer I've selected. Connecting to file servers is just as easy. Select a server, enter a password, and the Novell file server we chose appears just as though it were a local disk drive. I can access the server by pointing and clicking. When a user attaches a Macintosh to the network, network services are instantly available. A systems administrator is not required to reconfigure the network. I can connect to LAN Manager in exactly the same way. And I can access shared folders on any other Macintosh on the network too, if the user of that Macintosh has given me authorization. What makes networking so easy and access to so wide a variety of network devices so consistent is AppleTalk.
AppleTalk has grown into a very capable, comprehensive network system for building local area networks in an office, for building client-server applications. AppleTalk as a protocol suite is now the second most widely installed local area network protocol suite in the world. Novell's IPX-SPX is first, and AppleTalk has got the second largest number of nodes. I think that's a testimony to the success and the usability of AppleTalk-based local area networks. AppleTalk sets the standard for ease of use, ease of installation, plug-and-play operation of a local area network system out there.
AppleTalk is a complete network system that includes a full set of services and protocols, as well as interface standards for presenting information about network resources to users. And it's an integral part of Macintosh system software. AppleTalk operates over a variety of standard cabling systems, such as Ethernet and Token Ring. For Token Ring network connections, we've offered the Apple Token Talk card since June of 1989. The news from the Apple-IBM Alliance is this. Apple has licensed IBM's 16 megabit Token Ring technology. We're now shipping Apple's first product of the Alliance, a new card that will support both 4 and 16 megabit Token Ring networks. And we're using the same chipset on this Token Ring 416 card that IBM uses on theirs. So full compatibility is assured.
We've licensed AppleTalk to literally all of the leading suppliers of network operating systems, to Novell, to Banyan, to Microsoft for OS2 LAN Manager, to IBM as part of the Apple-IBM Alliance for OS2 and LAN Server, to Unix-based vendors, to digital. And so it's literally true today that no matter what your local area network operating environment and your LAN server environment, AppleTalk is there, it's supported, and the Macintosh can connect very, very well.
IBM has endorsed AppleTalk and has licensed the source code from Apple. They've already implemented AppleTalk protocols in a multi-protocol router called the IBM 6611 network processor. AppleTalk will also be implemented under OS2, so IBM's LAN server will support Macintosh clients. Macintosh users will connect to LAN server exactly as they now connect to LAN Manager, with the server appearing on the Macintosh desktop as an icon, the same way LAN Manager does today. IBM's OS2 servers are also used for applications that communicate using the NetBIOS network protocol. Under the Alliance, Apple will assist IBM in developing a translator between NetBIOS and AppleTalk. This means that OS2-based network applications, such as Database Manager and Communications Manager, will also be accessible to Macintosh clients. And for systems administrators, it means that Macintosh users can be attached to IBM LANs with minimal additional support. Now let's move from the subject of local area network connectivity to SNA connectivity. There are a number of products from Apple and third-party vendors such as Avatar that provide a range of SNA connectivity.
We already have an excellent SNA connectivity product from Apple in the form of our SNA protocols and services, or SNAPS gateway product. This product provides 3270 capability. It provides LU 6.2 APPC capability, allows Macintoshes on an AppleTalk network to reach out through a gateway to a wide variety of IBM machines in an SNA environment.
Here's how SNAPS 3270 works. To connect to a mainframe, I select the network zone and gateway. Choose Connect from the network menu, and the host system appears in a window. From there on out, the session looks just like any terminal session. The difference with Macintosh is that I can select any data that I want, copy it, and insert it directly into a Macintosh application. That simple capability can save IS untold hours of filling requests for custom reports. SNAPS Gateway can be used for direct SNA connectivity, or it can be used as an AppleTalk Network gateway. In that configuration, any Macintosh on the network that has SNAPS 3270 can access SNA services through this gateway. Since the SNAPS gateway runs on a smart NuBus card, the distributed sessions don't diminish the performance of the gateway Macintosh.
Now we're going to go beyond that and extend that gateway product in a couple of different ways with IBM's help. We're going to do a better job of integrating it into IBM network management products so that the Macintoshes on an AppleTalk network will be visible to IBM NetView network management consoles. We're going to put peer-to-peer SNA capabilities into the product so that IBM's APPN, this is the next new wave of SNA that makes it much easier to interconnect local area networks via an SNA backbone. Those capabilities will be in the SNA gateway. And we're going to be working with IBM on those things, in some cases using IBM source code as a way to get to market faster with those capabilities.
The good news about this enhanced interoperability is that you can build enterprise systems with the confidence that Macintosh and IBM environments will coexist seamlessly. You'll also be able to manage Macintosh network nodes with IBM's network management tools.
I think the real benefit that customers could see out of the relationship is that if Apple can translate their ease of use to hiding the complexities of particularly the big IBM SNA networks for end users, that would be a real benefit to both MIS in terms of limiting their support headaches and to the end user, allowing them to do what they want to do, which is get at a particular piece of information that they need to do analysis on and not have to spend their whole day navigating through the network and logging onto this, that, and the other system in order to get to what they really want to do.
Now let's see what the Alliance will do for Macintosh in AS400 environments.
In many cases, AS400s are purchased by users who cut their computing teeth on a Mac, and integrating the two products is a natural requirement. The wide range of PC support functions on the AS400 eventually be available to the Macintosh user as a result of the Apple-IBM Alliance.
There's a very natural fit between the Macintosh and the AS400. IBM has spent a lot of time and a lot of focus with the AS400, making it easy to use. In many cases, they're in small to medium-sized business where there isn't a huge IS infrastructure to support the machine. Or in large companies, we see a lot of AS400s in a distributed environment, remote offices around the world, around the country, small sales offices. The ease of use of the Mac, coupled with the ease of use of the AS400, is a real natural fit.
For AS400 connectivity, Apple will build a 5250 terminal emulator similar to its SNAPS 3270 and SNAPS Gateway. Also, PC support, AS400 services for DOS and OS2 machines, will be fully available to Macintosh. And finally, Apple will implement a data access language server for the AS400 that will provide Macintosh users with access to the relational database management system on the AS400. Data Access Language, or DAL, is a software product from Apple. It's a superset of SQL designed to link personal computer applications and SQL databases. Here's how it works. DAL software is installed on both the Macintosh and the host, such as a mainframe, VAX, or an AS400. A query from a Macintosh application is transmitted to the DAL server on the host, which in turn queries the host database management system. The results are passed from the DAL server to the Macintosh and presented to the user's application. In this example, we're using Data Prism by Brio Technology Incorporated to construct a database query. Just by moving the names of data fields to specify the information we want and how we want it presented. The Macintosh graphical user interface makes it easy for users to set up ad hoc queries by themselves. DAL can also be used by a number of off-the-shelf Macintosh spreadsheets and databases to query IBM DB2 and SQL DS databases and a host of other servers and relational database management systems, such as Oracle.
I think the bottom line on all of that work for an IS organization is that the Macintosh is very rapidly becoming, if it isn't already, a first-class citizen in IBM network environments, one that's very manageable, one that has IBM's stamp of approval, one that has IBM engineering resources and Apple engineering resources working to make sure that the products are quality, that they're tested, and that they're going to work reliably, and that an IS organization can buy a Macintosh and Macintosh networking products with confidence, knowing they're going to work in their IBM enterprise network environment.
Already, IBM has done extensive Macintosh integration testing at its multi-vendor interoperability facility, and the result is an installation guide that contains a great deal of configuration information that you might find useful. It's called IBM Apple Enterprise Networking Guide for SNA products, and it's available now through any local IBM branch office. The IBM document number of this book is Z325-60270.
The future of the Mac being extended and that experience and those applications being extended, coupled with the closer integration to the IBM infrastructure that exists in accounts and the data that's on those systems, makes the Mac actually a safer choice.
As part of their far-reaching technology alliance, Apple, IBM, and Motorola have agreed to cooperate in the development of a new family of processors based on reduced instruction set computing, or RISC. These processors will be called PowerPC.
Up until now, RISC technology has tended to be associated with technical workstations and with engineering and scientific computing. Apple's interest in RISC is in what can happen when we bring the price of RISC way down and make it an integral part of the mainstream personal computing experience. What can RISC processing power do for a mainstream personal computer and for a work group in a LAN environment? We think the future is very exciting with RISC technology.
4 years ago, Apple produced a film to dramatize its vision of the future possibilities of personal computing. It was called The Knowledge Navigator.
Jill Gilbert is calling back. Great. People ask all the time, when are we going to have a knowledge navigator? When is that going to be possible? That opens up a number of things. We can talk about speech recognition. We can talk about 3D in the user interface. We can talk about animation. All of these things improving what a personal computer is.
Let's put these together.
We also have to work on the system's ability to recognize patterns and repeat things on your behalf, this notion of digital agents. But to do any of those things is going to take a lot more horsepower in the basic system. And for that, we need RISC.
On the server side, in a workgroup context, the power of RISC is really essential to this business of moving applications off of mainframes and off of mini computers and deploying them in a local area network environment. It's going to take the kind of processing power that RISC-based microprocessors can deliver to run the relational database management systems, the image processing, the workflow systems. All of those kinds of capabilities are going to rest on the power of a RISC-based microprocessor.
The PowerRISC architecture is highly scalable, so that Apple will be able to incorporate PowerPC chips in products from low-cost personal computers and portables up through high-end personal workstations and servers.
RISC allows us to build Macintoshes in a few years' time that are fully 10 times more powerful than today's Macintoshes. Those future Macintoshes will be completely compatible with what we have today. They'll run the same programs we have today, but they'll open up this universe of new things we can do.
Apple and IBM will team up with Motorola, supplier of the 68,000 series microprocessors used in all current Macintosh computers and world-renowned for design and manufacturing of integrated circuits.
One of the things that we have done in this alliance is we have a Customer Design Center, or CDC, formed by Apple, Motorola, and IBM, where all three of us have engineering teams that are working jointly on various parts for the PowerPC family. There are 4 PowerPC microprocessors currently under design. The first microprocessor is being designed jointly by IBM and Apple and is based on their current Rios single-chip implementation. That part will have a performance level that is equal to the mid-range to upper end of today's workstations that you can find available, and we will be putting this in our mid-range to high-end products approximately 2 years from now.
In addition to this first chip, 3 other chips are being designed from the ground up. Engineers from Apple, IBM, and Motorola are collaborating on these designs at a new facility in Austin, Texas, called the Customer Design Center.
And there are 3 parts in that family. A low-end part, which is used for portables and low-end personal computers, a mid-range part for the standard desktop, and a high-end part that has applicability in high-end desktop workstations, servers, and mainframes. This is actually unprecedented in the industry. This would be the equivalent of Intel coming out with the 486, the 586, and the 686 all at the same time.
PowerPC is based on the RISC architecture now being used in IBM's RS6000 workstations, called Power, which stands for Performance Optimized with Enhanced RISC.
IBM actually has the best semiconductor technology in the world at this point in time. Currently today, they can manufacture devices in 0.5 micron, 4-layer metal technology, which allows you to have a much denser device and also a much lower cost device.
Jim Norling, President and General Manager of Motorola's semiconductor product sector, talked about the prospects for PowerPC.
Apple and IBM both will use the PowerPC in future systems, but we're all strongly committed to making this a truly open architecture. And Motorola will make PowerPC widely available through our worldwide marketing network. Moreover, the 3 companies intend to form a new industry organization to promote PowerPC to other manufacturers, software developers, and end users.
So we're going to see a very broad family of systems from many different vendors that are nonetheless going to be binary compatible with one another, and that means a leverageable software base.
If you're enjoying the advantages of Macintosh computing today, you're safely on the road to the future. PowerPC won't leave you behind. Rather, it will offer the performance to enable expanded capabilities and new applications.
In 2 or 3 years, hundreds of thousands of Apple customers will have a chance to experience this highly advanced technology by choosing the PowerPC-based Macintosh. Now, we believe PowerPC Mac will be the highest volume RISC computer in the industry, and that it will be our mainstream Macintosh by the middle of the decade.
Apple and IBM will jointly develop a Unix-based open systems platform called Power Open, based on OSF1. Power Open will be marketed independently by both companies, and it will be licensed to others as well.
One of Apple's goals in this alliance was to enable our enterprise customers to run Macintosh applications from the very smallest desktop Macintosh all the way up through very large servers and mainframes. An important part of that strategy is the piece we call Power Open.
Our work with IBM on Power Open is really work to combine the best of 3 different technologies. Apple's AUX, which is about personal computing use of Unix, Mac in a Unix environment. IBM's AIX, which is a high-quality, industrial-strength implementation of Unix with over 4,000 applications that are available for it today. And then thirdly, the PowerPC RISC technology, and using that as the underlying processing power.
Power Open will play a key role in Apple's product offerings for enterprise computing. On the one hand, Power Open will function as a workgroup server and applications delivery platform for client-server computing. It also offers unique advantages as a high-end personal workstation.
We see Power Open as really being a very excellent next-generation server operating system that we're working on today. You know, much of what goes on in local area networks today is basic file sharing and printing in support of PC users. But that environment is changing very, very quickly to becoming a client-server applications environment, where relational database management system, where applications are running on that server in support of the workgroup that participates in that local area network. That takes a whole different level of capability than today's network operating systems are able to deliver back there on that server platform. It takes the power of Unix to do that. Unix has already emerged as the leading platform for running relational database management systems. We think Unix is going to play a key role in the kinds of directory services and naming services, in pulling together heterogeneous networks and linking them together in internets. Power Open as a Unix-based environment is ideally positioned to do that. It also, though, has excellent ease of use and usability characteristics. Power Open-based servers will be servers that can be administered by mere mortals. Servers that I can put in the closet and rely on a key operator as opposed to a systems administrator or a network administrator to run. And so the ease of use...
Apple also sees an important role for Power Open on the desktop.
At the high end of the personal computer market, we're seeing a very rapid convergence between what have traditionally been low-end technical workstations that are now coming down in price and crossing over into the commercial area, and high-end personal computers becoming more and more and more powerful. And this emerging category of a business workstation, a personal workstation, as the high-end desktop. Operating systems are also evolving very rapidly to provide an industrial-strength operating system foundation for that desktop. In Microsoft's case, that's the target for Windows NT, is that high-end industrial-strength desktop. It's what IBM is targeting with OS/2, and that is the target of Power Open as part of the Apple-IBM joint development agreement.
What's really going to drive the Power platform is the merger of RISC with the Mac application base.
What we can offer to a customer is a compatible family of products that can run off-the-shelf Macintosh software that range all the way from portable devices that I can carry around with me in my briefcase through mainstream $1,000 to $3,000 desktops all the way on up into this high-end emerging personal workstation category with a Unix-based desktop that can still run that industrial-strength personal productivity software.
IBM and Apple will support a new Power Open consortium to foster the broad adoption of this open system.
Power Open is the core operating system that comes out of the Apple, IBM, Motorola cooperation around Unix. It's not a complete product in and of itself. What happens is any vendor who standardizes on Power Open needs to take Power Open and implement it in a product, in a personal computer, in a server, in a time-sharing system, in an online transaction processing system. I think one of the most serious misconceptions that has arisen out of the Apple-IBM alliance is this notion that somehow IBM is going to be selling Macintoshes, or that IBM will have products that are Macintoshes or just as good as a Mac on out in the future, so that there's no need to look at a Mac or no need to look at Apple. Let's take a look at what's actually happening. In the Power Open environment, what we are doing is building with IBM a Unix-based system that can run Macintosh productivity software and has a Macintosh user interface. Nonetheless, it's Unix.
That operating system, while being standard and allowing you to choose among many platform suppliers, has the characteristic that it takes a lot more memory and hard disk to run it. And so typically a system there will be a 16 megabytes of memory and a 400 megabyte or greater hard disk. Those systems cannot reach the price points that the Macintosh systems can reach.
For people who are doing heads-down business work and want to take advantage of the Macintosh ease of use and experience, as well as the graphical application suite that's available, it makes a lot more sense to buy what's a much lower cost Macintosh solution today, particularly with the new machines, the Classic and the LC. Because right now, to run that, you're looking at buying a $10,000 to $20,000 IBM machine to run Macintosh applications.
So I can buy a Macintosh-based personal computer, a Mac System 7-based portable from Apple. I can also buy Power Open-based servers, Power Open-based business workstations. They're all compatible with one another. They can all run Macintosh software, and you've got Apple behind them making sure that they all integrate well together. It's Apple that can provide that range of systems to a user. The other vendors who are going to be on Power Open start with a Unix-based system and move upwards from there.
The technology alliance between Apple and IBM will establish an equally owned joint venture company called Taligent to build a new kind of operating system that will fundamentally change the economics of developing application software. Taligent will introduce a totally object-oriented operating system by the middle of the decade. Here's what Jack Keeler, president of IBM, said when the formation of Taligent was announced.
We hope to remove the barriers to software development, which have created backlogs of applications that now wait years to be written. We intend to liberate developers, large and small, through programming technology. Technology that has the promise to transform the information industry, much the same way that interchangeable parts revolutionized manufacturing more than a century ago. What's more, we plan to dramatically improve not only the productivity of individual PC and workstation users, but entire enterprises as well.
Object-oriented systems today and going into the future are known to make the process of development of complex applications go much faster, much less expensively. We've already seen those benefits. If we build a system that's wholly object-oriented, we'll get a tenfold improvement, we believe, in programmer productivity.
Realizing the full benefits of object-oriented programming will require new approaches to software development.
Looking ahead through this next decade, we see two discontinuities occurring in this industry. One is around the operating system platform in this industry, and that current existing operating systems really can't keep up with current hardware advances. But even more importantly, we think that there will be a discontinuity in programming paradigm. That existing programming paradigm used today, which is primarily structure-oriented programming, has really reached the limit of its capacity and is holding back new application development. The operating system technology deployed in the industry today is what we call monolithic.
The object-oriented approach is significantly different from these monolithic approaches.
The object-oriented technique that we're using is to break the system up into a large number of objects or class libraries and to build a system that again, does not have this monolithic kind of nature to it, that has sort of a Lego block kind of nature to it, that you can take these components, once built, plug them together and build applications or build services or even build system extensions.
Object-oriented systems have numerous advantages.
We think the system will be much more extensible and actually have much higher quality than an existing monolithic system, because as you modify an object, it doesn't ripple its way through the system. Well, we also believe that those benefits are that we'll deliver a system that has much more longevity, a system that's designed to last 30 years, designed to be portable to multiple architectures, much more scalable because it is object-oriented. You can pull objects out of the system and scale it down or scale it up, and much more extensible because the objects themselves can be extended and that new function can be included into the system sort of seamlessly.
Apple is contributing its investment in this object-oriented software environment, which we called PINK for several years. We're contributing all that we have done in terms of building this from a technological standpoint.
Apple has already produced more than 1 million lines of code in this quest, a tremendous jumpstart. And IBM is providing object technologies, including extensive work on the system object model.
The very exciting aspect of the Taligent object-based system is the fact that it's completely open, that it can be, that companies, OEMs, system vendors can take the existing environment and very easily produce a derivative work of it.
The Taligent system will also be very adaptable in terms of its hardware interface.
We do think, by the way, that PINK, because of its object-oriented nature, sort of liberates the hardware vendors today, in that because of the object-oriented nature of the system, you can very easily adapt a new piece of hardware to it. We'll support both the Macintosh 68000 based architecture, and we'll also support Intel. And another one of the alliances that Apple and IBM initiated was this PowerPC architecture, which is a new RISC-based architecture, and the operating system is designed to be ported to that architecture as well.
We want other people to use the Taligent system so that we can have an enormous community around the Taligent architecture in terms of applications, tools, custom systems integration, and so forth.
Taligent will introduce the system mid-decade, but we'll be showing it to potential OEMs much earlier. At Apple, the Taligent system and Macintosh will coexist.
When the Taligent system is available in a few years, Apple will develop separate product lines for the Macintosh and for the Taligent-based systems. They'll be very complementary. They'll work together. There'll be easy data exchange. There'll be applications compatibility between the two systems.
The Taligent system represents a significant departure from the operating systems of today. Jim Canavino, IBM Vice President and General Manager, Personal Systems, contrasted Taligent's true object-oriented operating system to other approaches where object layers are added to an existing monolithic operating system.
Yes, object technology is here, and it's already being used in limited ways by layering it over existing operating systems to help speed up the process of building application software. The real productivity gains by orders of magnitude will occur when network and communications, file systems, and device drivers, which are embedded in the kernels of today's operating systems, are freed to become objects themselves. That will be the turning point for the way applications are produced. A revolution, if you will.
So just a very substantial difference between what Microsoft might be doing with new technology, their NT environment, which is a monolithic system, and what we're trying to do with this object-oriented system.
Apple and IBM hope that with their support, the Taligent operating system will become an important industry standard. But you don't have to wait until Taligent's system hits the market to start getting the benefits of object-oriented technology.
Invest in object-oriented software development today. Get started. Teach your people this technology. It's a very easy technology for professional programmers to understand. Move forward. Get on the bandwagon, and it'll open up all sorts of possibilities to using the future Apple Macintosh product, which will be highly object-oriented, as well as being able to easily incorporate Taligent-based systems into the future.
Apple and IBM have announced the formation of a joint venture company to be called Kaleida that will serve as the catalyst for the development of new multimedia technologies and products.
Select the nozzle. Modify. Let's see noise test 3 again.
This video was made a few years ago to illustrate the vision of personal computing that Apple has been pursuing. It shows how multimedia could dramatically change the way people use computers.
Regulations. Noise.
When the Apple-IBM Alliance was announced, Jim Canavino had this to say about the importance of multimedia.
Until now, computers have been at a primitive level, responding precisely to whatever question has been asked. Multimedia, as it engages our multiple senses, offers us multi-dimensional answers. It has the ability to change not only the way people use computers, but the very reasons they use computers. But we know multimedia won't meet its potential as an integral part of computing until uniform specifications and formats are available across the industry. Software developers and those who create the content, music, animation, video, and graphics, have no single target for integrating multimedia into today's computers. So their risks have been much too high, and it's inhibited the appearance of neat new applications.
Multimedia is a very fragmented marketplace today. And one of the key reasons it's fragmented is because there's a general lack of standards in the multimedia area. And probably there's 3 areas of standards in multimedia. At one level is the standards around data compression and how to represent time-based media, video, animation as a sequence of bits. And at that level, we have things like MPEG and JPEG and various compression algorithms, but also specifications like the QuickTime movie format, which we've just brought out and published. But then when we step up to the next level, the next stage of standards for multimedia has to do with the programming language, the scripting language for how to construct interactive programs from a sequence of these video clips or animation clips and how to navigate through them. And this area is basically unexplored by any technological answer. And then the third level is the communications problems associated with transmitting this kind of new media over, say, a cable television wire, over a broadcast satellite, over the telephone lines, over ISDN. So we joined with IBM to form this company called Kaleida, whose charter it is to work on those 2 high levels of standards, leveraging the investment that Apple has already made in the data compression and the video encapsulation formats, the movie formats, and investing in the scripting technology and investing in the communications technology that's going to be necessary to make multimedia successful. That's the whole core of the Kaleida program.
QuickTime is Apple's key technology contribution to Kaleida. QuickTime extends the capabilities of Macintosh beyond text and graphics to incorporate time-based data types.
QuickTime is an important new data standard for this video animation, time-based media, sound and video together. And we're way ahead of the rest of the industry in terms of the specification and the capability.
Using QuickTime, a digitized movie can be pasted into any QuickTime-aware document, like this one created in MacWrite 2, making it easy to incorporate dynamic material into business documents, training materials, and so on. And because QuickTime is software-based, it's far more adaptable than other hardware-dependent multimedia solutions.
There's no special hardware needed. Almost any Macintosh, color or black and white with a 020 or better, can play back this media very effectively, this new data type very effectively. That makes us unique. The rest of the industry is trying to convince people to buy a special PC with a couple special cards in it, CD-ROM, a lot of wire, a lot of complex software, and assemble all this stuff and deliver this thing called a multimedia personal computer, an MPC. The only thing a user is getting by buying an MPC system is a lot more complexity in terms of how it fits together. Macintosh comes out of the box, it has sound in, sound out built in. You drag this new QuickTime software for the moment, and in a few months it'll be just included, and you're instantly a multimedia computer. There's no fuss, no bother, no complexity. It's just a Macintosh and it's multimedia.
Apple and IBM hope that with their support, Kaleida's standards and tools will be widely adopted, and developers will have the confidence they need to move the advantages of multimedia computing into the mainstream of enterprise systems. As you can see, the Apple-IBM Alliance affects the future of computing across the board.
For IBM, the scope of this alliance is truly unprecedented. With this alliance, we believe we have the elements of truly a new era. Visionary people, state-of-the-art technologies, world-class design and manufacturing. They're recognized in three innovative and very successful companies, Apple, IBM, and Motorola. Apple's renowned ease of use, system software, a large applications base that commands a unique loyalty from its customers, IBM's leading-edge semiconductor technology, system software, and our unmatched experience in enterprise networking. And Motorola's strength in communications, circuit design, chip manufacturing, along with its passion for quality, a passion that we all share. By combining our expertise, Apple, IBM, and Motorola believe this synergy will open vast opportunities for the whole industry, deliver new power into the hands of users, and forever change the way that people work.
The Apple-IBM Alliance is a comprehensive set of initiatives, each tightly related to the others, building the technologies that will help you to enhance your systems more easily and manage them more efficiently, and helping you and the people in your organization to do their jobs more effectively.
Now that you've seen the scope and breadth of our alliance with IBM, let me emphasize that the benefits to our customers start today with products that tightly integrate Macintosh into IBM's networks, servers, and legacy systems. Better network integration has been the goal of a number of technology alliances that we've formed in the past. For example, our alliance with Digital, which dates back to 1988, provides enhanced integration between Macintosh and digital networks. In fact, the PathWorks for Macintosh suite of products has made Macintosh the best integrated personal computer in the digital network environment. And we're continuing that alliance with new releases of PathWorks. The alliance with IBM means that the transparent networking capabilities and already impressive connectivity of Macintosh will be further enhanced. That you'll have better tools for managing networks that combine Macintosh and other platforms. That application development will be streamlined and support will be greatly simplified. means that Macintosh will continue to be a superb choice for leveraging your systems investment today and for building the cooperative processing systems of tomorrow. If you've already committed to Macintosh, you'll soon see the benefits of the enhanced interoperability, and you'll be pleased to know that you're already on the way to the systems that you'll be building in the future. And if you've not yet considered Macintosh, I invite you to do so. You'll find that Macintosh has grown since its introduction in 1984 into a full-featured, well-connected desktop platform. Take a closer look at how Macintosh can help you meet your information systems needs today. And consider the smooth migration path it will provide to client-server and object-based environments in the future. I'm confident that you'll be very, very surprised and pleased at the rich set of advanced capabilities that Macintosh provides. Thanks so much for joining us today.